Hello College Biology, this is another video in our Basics of Chemistry series, and we're going to wrap up a discussion about subatomic particles and then mention universal forces before we get into the complexities of the model of the atom. So let's start with how do subatomic particles change an atom. So we start with an atom here, and things can occur, nuclear reactions can occur, fusion and fission, where we actually change the number of protons. We can add or subtract protons. Well, since atoms are defined by their number of protons, because that's their atomic number, that leads to different properties. So if you actually change that, you will change the element. If you take gold and add protons to it, it'll become a larger, heavier element, and if you subtract protons from it, it'll become a lighter element. That's just changing the identity. Now, if you change the number of neutrons in an element, well, you are going to change the mass, but it's going to stay the same element, and we call those variations isotopes. So you will create an isotope. And if you change the number of electrons, either gaining or losing electrons, you will change the charge. It will become an ion, and it'll be either positively charged if you lost electrons or negatively charged if you gain electrons. But it'll still be the same atom. So in these two, you retain the element, but when you change protons, you change the element. Now, let's introduce the four nuclear forces. The four universal forces. The first is one that we've mentioned before when we talked about how charged particles behave. It's electromagnetism, and it's very strong over small distances, but it doesn't work over larger distances. And its behaviors are that opposite charged objects attract, and then similarly charged objects repel. The next universal force is gravity. Gravity attracts any objects with mass. And it works over incredible distances. It gets weaker the further the distance is, but it still works. There's still an attraction right now between me and, Neptune or something. So it's still, the pull is there. Other pulls are stronger, but I'm still being pulled toward Neptune too. There's then the strong nuclear force, which is something neutrons use to keep the nucleus together. We're going to talk more about that later. And then there is the weak nuclear force, which we won't really be talking about later, which is something that occurs in unstable atoms when protons become neutrons and release radiation. We are not going to go into that because that's really getting down to physics and not really a part of typical biological chemistry. So our review for this video is that if you change the number of protons in an atom, you'll change the element, and that will change its properties. If you change the number of electrons, you will change the charge of the atom, and you will create an ion. If you change the number of neutrons, you will change the mass, and you will create an isotope. And the four universal forces, which we will discuss when we talk about the model of the atom next, is that electromagnetism, which works on charges. It means that opposite charges attract, like charges repel, and it's very strong over small distances, but it doesn't work over large distances. The second is gravity, which affects all objects with mass, and it attracts the objects with mass, and it gets weaker over distance, but it continues to work over all distances. Then we have the strong nuclear force, which affects the nucleus of an atom, and it allows neutrons to pull other neutrons and protons together. And then finally, the weak nuclear force, which converts protons to neutrons by releasing even smaller particles. This creates nuclear radiation, and that's as much as we will ever say about the weak nuclear force. I hope this helps. Struggle well.